Okay, I can't hear anybody. I don't know who's talking.
Okay, okay. Welcome to all of you today. Matrix Polymers UK is proud to associate with Roma as a glad to witness the evolution, growth, and development of the Indian rotomolding industry. Matrix stands committed to support Roma and all its member fraternity, not only with world-class polymers for rotomolding, but also technical know-how, research and development, and manufacturing expertise. Ladies and gentlemen, Roma Rotomolding Association of India has initiated a wonderful series of interactive webinars. These webinars create an opportunity for members to share knowledge, experiences, information, and learning. The ideal platform for members of the rotomolding industry to network, connect, and collaborate. On behalf of Roma Governing Council and in representing Matrix Polymers, it is an absolute privilege for me to welcome the guest speaker for the webinar today, Mr. Gary Lategan. Gary, as most of you already know, is the founder and owner of Roto Solutions. He's a veteran consultant with more than 35 years of experience in rotomolding, by all means an expert in his own right and a wonderful human being. Gary does not need any formal introduction because the name itself has become synonymous with rotomolding processes across the globe. We are proud to have him with us today. Gary's rich experience and expertise will no doubt be on full display in the course of this webinar, and we hope so will be his infectious sense of humor that makes him a favorite at such events. So without taking much of your time, ladies and gentlemen, allow me to present to you Mr. Gary Lategan. Thank you, Gary, and welcome to the webinar. Thank you, Roma, for according this honor to Matrix Polymers. Thank you.
Before Mr. Gary, I request Mr. Mukesh Bhai to give the this presentation, how the rotomolding, post-rotomolding things will be there after the COVID-19. I request Mukesh Bhai to give the presentation, then Mr. Gary will.
Mukesh Bhai, you are the presenter now, so you can go ahead with that.
Hi all.
I request Mukesh.
Yeah. Hi, good morning everybody. Welcome Gary. It's fantastic to have you again back to Roma. It's the 4th webinar session of Roma, which is going success throughout the world. I foresee a very positive sign for rotomolding, especially in the care sector, that is the COVID waste sector, the hospital sector, and the hygiene factor, as there's going to be a lot of demand for the hygiene sector. I'm not naming, but there's a very high quality rotomolder in India, and he has developed a fantastic product for rotomolding sector in the dispensing of spraying systems. The way the stimulus has come of 20 lakh crores into the economy is going to help all the MSMEs, and I think most 90% of the rotomolding sector falls under MSME. The MSME is going to see a huge demand, and especially the overseas companies which are coming forward today in India to look for sourcing their products. Rotomolding will see a great leap into the economy. I wish success to all the rotomolders, and be prepared, go for high tech. We saw the presentation of Mr. Satish Gokhale looking into designs. Indian rotomolding need to change for the rotomolding design, and let's the new millennium, which I would say 2020 is a new millennium for all of us. Let us have a good product coming out with a good facility, and listen to these world-class speakers, what they have to offer to us, and implement on the shop floor rather than we owners listening to it. I would suggest this presentation should, if possible, for whoever factories are available or managers are available, they should look at these presentations for us to bring forward this. It's almost 15 years we have been listening to world-class speakers in India, and we have been attending international shows, and we can see that most of the products are available into India. The automotive sector, the toy sector, equipment sectors, a lot of things are going to come into this country. So let's get the best quality of the design, machinery, products, all are available into our country, fortunately now. So let's give the best boost to rotomolding and let rotomolding be a sector to be reckoned with. I wish all the success to everyone and a safe into your factory, into your families and friends. Thank you. Over to you, Gary.
Disaster. Okay, there we go. I don't know, sorry, I've got this sidebar that's interfering with me getting to my actual start of my presentation. Just let me, I don't know why this is sitting in the way. Just moving it. And there we go. I should get up and running. Right? No. Sorry, the meeting bar is covering my presentation bar. There you go. Okay. Hopefully that's it. All right. Can you all see my web presentation? Guys, can somebody just confirm that you can see me clearly?
Yes, we can see you, Gary.
Yeah, it's okay.
Presentation is also.
All right. Thanks. All right. Okay. Thank you. Right. Good morning, guys. Great to be back. It's not with you guys in India. As we all know, we're in lockdown. I'm just battling a little bit with understanding this format. I haven't worked on this format before. This is big. Okay, it's now running. Okay, I was asked by Roma to do a presentation or webinar, and the topic was what's happening inside the mold while processing. So I'm just going to, normally what I would do in any of my presentations or workshops, as you all know, I'd ask people to stand up who don't know me and introduce themselves. And I would spend a bit of time just getting to know who I'm talking to. So it's a bit strange for me sitting here not knowing who I'm talking to. I could see a couple of friendly faces and some new ones. So welcome to everybody. And I'm just going to give a little bit about myself because there might be a lot of people who don't know me. And I don't know who's going to tell me to slow down if I'm talking too fast. But tell me if I'm talking too fast. Somebody, okay? Because I'm accused of that all the time, so I'm so consciously trying to do it. Okay, so this is my first webinar. So it's actually quite nice to be doing something different for a change. Whereas in the past I've always done things live. So let's see how this goes, and let's see what benefits there are for everybody here. Okay, that's just this camera. Right, for those who don't know me, I started rotomolding in 1979. So I'm coming up for my 40th. In fact, I've just done my 40th year in rotomolding. And we were converting 1 ton of polymer every 2 to 3 months. It was a very basic home-built setup. And when I sold in 2007 and started consulting my journey, traveling the world and helping people and solving problems around the world, we were doing 350 ton a month, producing 3,500 rotomolded parts a day. We were not tank manufacturers. I had one machine in the corner making tanks. And for those you don't know, we did 5,000 liter tanks on one machine, and we did up to 72 in a day with one operator. So we were a high-speed factory, and mainly in technical and small parts. With only 4 rock and roll machines and 6 turret machines, all home-built. I designed and built all my own equipment in those days. Just to give you some background on myself, that is where I started. This was about 3 years in, 1981, 2 years in. You can see 3 little machines, and right in the back corner is our first pulverizer that we also built. By 2001, we had upgraded ourselves to full automatic, some of the best machines in the world, I thought at the time, running very high speed and fully temperature controlled, which for those of you who know me, I'm Mr. Temblogger. And those who don't know me, you'll get to know about Temblogger as well during this presentation. I was fanatical about trying to be the best. Here's a picture of the environment of the machine, air-conditioned tables, guys sweeping there while they're working, they're cleaning. We eventually issued everybody with white jackets to make sure that they stayed and kept clean. You can see the condition of the machine in the background. The molds are black and they're not dirty. They're black because they should be black. The machines are nice and silver. So yeah, I was fanatical about trying to be the best and do the best quality. And this product that's being molded here, by the way, was a job we took away from blow molders. So I'm very proud to say, even in small products, we took products away from blow molding because of our high speed. We could produce like 1,200 of these parts a day. All right, I started consulting in 2004. And this was about 3 years before I actually sold my business. Because for those of you who know Professor Roy Crawford, a very, very good friend of mine, and he was considered the guru of roto molding, visited my plant from 1999 every year until 2004, and eventually convinced me to get out and start teaching. Because in '86, I started traveling the world to learn. I went to Australia, '89, I went to Europe, '94, I went to America. I went all over the world to learn, and wherever I went, I actually found I could teach. So Roy actually visited my plant and eventually got me to go out and teach. And that's where I am today and why I am here today. Because now I'm working in it's well over 70 countries now, hundreds of molders around the world. So Roto Solutions, which is my present company, was originally a separate R&D company with a separate budget. We actually moved it and started it on a premises across the road from our roto molding plant to absolutely divorce it totally, so that it was a separate company. And the objective of this company was to find better ways to mold, okay? Because I had all these amazing ideas and I always wanted to try things, but we played in between and when we could production. But what we did is we actually set up a separate little machine. I ran a mold shop on the other side. We did all design, we did all mold making and everything at Roto Solutions across the road. And our goal was to become world leaders. And when I sold 3 years later, I think we had advanced so much in those 3 years. I think it took me about 20 years to get to where I was, and in the next 3 years, we just absolutely flew. And the reason I'm saying this is what Mukesh said earlier, a little bit about me is, about yourselves and everything, is we've got to actually listen to people, we've got to listen to ourselves, and we've got to go forward. And after COVID, I think the world is definitely going to change. It's going to be a huge difference. It's going to be another world with a lot of opportunities. People are going to go bankrupt. People are going to start all over. New people are going to see opportunities and come into our industry. I think we have to be on top of our game, and we have to have a different look at this whole industry of ours. Because as you all know, our industry used to be considered the dark ages industry in the plastics industry. And hopefully myself and lots of other people in the industry have made huge changes to that. But we still considered the cheap, and everybody says it. I hate it when I see presentations but it's easy to get in and it's cheap to get in, and it shouldn't have that. We shouldn't have that. We should say we're an awesome industry. Get into our industry. Come join us because we can do amazing things. Not we're a cheap industry, or we're the easy way to get into the process, or unfortunately, I heard even the previous webinar guys mentioning things about cheap and easy. It's almost a selling point for some people in our industry, and I try and fight this. It's a fact that will probably never go away, but start thinking different. That's all I ask you to do. With this in mind, it gave me the opportunity to divorce myself from our factory, which ran 24/7, 365 days a year. Actually, that 365 days should be changed to 360 days a year. Sorry, I don't know why I put 365. We actually closed between Christmas and New Year. And every Christmas and New Year, even though our factory was cleaned every single day, we still shut down for 5 days to revamp and do all the things we want to do in the factory. And this is another thing that I'm just bringing some points up about myself and what I think. You must all have a serious look at yourself. And the only reason I'm doing this is because of COVID. I think the people who come back and open their factories, the ideal time to be cleaning factories, sorting out things, having mindset changes. Come back with a new clean factory, with a new clean slate. We took 5 days to sort out our factory to be absolutely where we wanted it for the next year. We've got weeks and months now, so have a good look at what you can do. Can you not get somebody in even just to start cleaning, wiping down, washing? So when you come back with a new clean, fresh idea. Yeah. So I don't want to preach too much, but guys, we really have to get going forward with this industry. As Mukesh said, we've been bringing people to India. I consider myself as one of you guys. That's why I say we've been bringing. But between Star, I started with SARD and then Star, and now Roma. We bring world-class people, world-class events, world-class presentations, world-class consultants, world-class material, world-class everything to India. And 90% still stay as they are. And hopefully that's going to change. But even though we were advanced, by 2004, as I said, we were a very advanced company. We made all our own machines. Okay, we built, I designed and built all my roto molding machines, designed and built all my extruders, my pulverizers, my grinders, my compounding machines. We did everything. We bought reactor material, we customized our polymers, we compounded our own material, we ground it to our own spec, but I was never satisfied. I still wanted to be better and better. And 90% of what I have taught you guys, and a lot of you know about me, is all stuff that we did in-house. It's not something, I'm not talking to you about other people's experiences. So far, I'm talking about my experiences. And with this divorcing myself and going over, it gave us a chance to even move much, much further. And as I said to you, basically in 3 to 4 years, I would say I improved the factory almost tenfold. That's a little bit extreme, but it was incredible how we jumped forward. Okay, there were other events which I'm not going to get into, which took place in my life that helped me do this as well. Internal personal matters and things, but it afforded us an opportunity to jump forward. So in my opinion, COVID is the best. I haven't put it anywhere in my presentation, by the way, because I'm so sick of the word COVID and lockdown. But yes, my last thing I'm going to say on COVID, it's a new world. Have a new, fresh approach to it, and think differently, and go back and think what you can do to change your factory, your life, and this industry. This brings me to why I'm actually here today. Okay, enough said about myself. Just a couple of minutes. As far as I know, I've got 2 hours. 2 hours is a long time for me to talk to myself on a screen. So hopefully we can have a bit of interactiveness. I don't know, has Lowell joined us yet? Lowell, are you there? Can anybody see Lowell? He was going to do some.
Very much here. You're doing very well.
Good, Lowell. I can't see you.
And you're looking good.
Okay, good. What I want to know, Lowell, is remember you said to me you might want to stop me and do some interpretation, okay?
Sure,
So,
if there is, I might do, yes.
Okay, so I don't know how you. If you can ask people to, I don't know how they tell you if they need to know what I'm saying, but and then how are you going to stop me, or are you just going to interject?
I will intervene if required. Vipul, Manoj, I think you can announce to people that they can ask questions if they have doubts or if they want any clarification.
Okay, are they going to type in the chat?
Gary, there is an open session afterwards, after your session. So if anyone is having the questions, they will write us, or they can ask you directly.
Okay, it wasn't about the questions. Lowell brought up that there are a lot of people who do not speak English.
Okay.
And he just thought maybe he would like to just make sure that they get
English, but they're not very proficient, and sometimes they might miss some of the things you're saying. This is why I requested if you speak a little slower, they should be able to catch on, and they have a chance to ask them. Yeah.
As you know, it's difficult for me to slow down. I'll have to consciously every now and then take a sip of my coffee or something and think, but just anybody, please just say slow or something. If I'm going
I keep reminding.
Okay, right. Okay, because now we're going to start some of the reason I'm really here. The other part was just a little intro. So I'm not too worried if people didn't get everything I said there. But from now on is what you've asked me to do. And I'd just like to, fortunately, what I've done, because it's a web seminar, I've sat and found a lot of videos. And even if anybody's got a question, I could maybe find a video. I've got so much information on my computer. But let's see how it goes. Okay, with that, we'll continue. What's happening inside the mold while processing? This just happened to be an obsession of mine, okay, when I started roto molding, because for those of you that saw the photo, the beginning of when I started, and I'll just run back there quickly, there, I started in 1979. But as you can see, my machines, even though they rock and roll, the first one in the front here is the first one I ever built. No machine, nothing had rocked by hand. The reason I got it up there, it was closed. It was totally closed. And if you see the molds there, sorry, there's somebody who's got quite a bit of interference on the mic. I don't know whose mic's on it. It sounds like there's water running. I don't know if anybody else can hear it, but hopefully they can switch off or do something. But this mold, as you can see there, totally closed. The vent tube was through the shaft. So we would stand outside the mold in 1979 and we look at the machine and spin it and we'd say, wonder what is happening inside the oven. Okay, wonder what's happening inside the mold, inside the oven. Okay. So, unlike a lot of you in India today, you still have open molds, open vent tubes where you can take torches and things and look inside. From day one, I could never see inside my molds. I never had an opening big enough to look inside. So that became my obsession. I want to stand there and actually know what was happening inside the mold. And for that reason, it was a passion of mine. And my motto in those days was measure. And if you can measure it, you can control it. And if you can control it, you can improve it. But one of the things we could never measure was what is actually happening inside the mold. So I started a journey of trying to discover what is happening in the mold. And as I'm saying, I'm a little bit ahead of myself on this slide. I think most get a feel of what's happening in the mold. Now, I'm going to refer to India in specific all the time because this is mainly for India, and welcome the 1 or 2 international guests. I believe there might be more joining us later. Some of them said they're not getting up this early. I'm very proud of Anthony, who's sitting in Argentina at 2 o'clock in the morning. So yeah, nobody can beat that one so far. But to look inside the mold, if it is possible, like on R&R, which I've just explained on my machine, it was not possible. Most of you will use torches and mirrors, again, if it's possible. But then if it's in a turret machine, carousel machine, shuttle machine, it's not that easy. Now you've got to start cutting little holes in the door, and while the mold slowly comes past the little window, you try and look inside to quickly see what's happening. Gives you a second. And I must say, I'm very impressed with some of the operators, how well they can produce a fairly consistent quality. And I'm not insulting anybody, but when I say fairly consistent, that's all they can do. I've never seen a guy who can get it perfectly right every time. To most, they will look inside and they'll say, okay, let's go out now. Or he'll want to go another turn, which, because most machines turn so slowly, and by the time it comes back again, it's almost gone to overcure. And so you can't expect operators to really control what is happening inside with a torch. And in some very, very rare cases, a guy will stick a mirror in as well to have a look. In that case, you have to obviously stop the mold from rotating. You can maybe spin it, etc., but you can't rotate and spin at the same time. So when it's possible, some of the operators do a fairly good job by looking inside with these pieces of equipment. But Roy Crawford, as I mentioned him before, did us an amazing, in my opinion. It's just something that blew me away. Favor. He and Queen's University developed a thing called the Roto log. Now, it would be so nice. I've been on web seminars, by the way, this week. My brother's very big in web seminars, and he invited me to 1 or 2. It was about online marketing and Facebook and all sorts of other things, nothing to do with roto molding. But their platforms that they use, and I'm going to sit and talk to Roma, they have platforms that they use that are similar in price to this, but you can vote, I can get immediate feedback. It's far more interactive and live. And it would be awesome if I could now ask you who knows about Rotolog and see what percentage. This is what these other seminars do. So unfortunately I can't, and I'm talking to myself. So at the moment, what I'm just saying to you, I saw this in 1999, sorry, 1989. I heard about 1989. No, sorry, 1989. It was for me when he showed us a presentation and he said, look what we can see inside the mold. Okay, we have a trace that tells us what is happening inside the mold. I said, that's not possible. It's got to be black magic. It's not possible. The world had never seen this. It was their launch. It was 20-something years ago, whatever it was. I think it was almost 30 years ago. Yeah, it's 30 years ago. It was well, 29 years ago. It was amazing. It was. I just said I have to have one of these things. And when I went and asked him what the price was, I also said to him, "You've got to be joking. You're kidding me." I said, "That's more than my whole factory cost me." Okay. At that stage, I think I had about 4 machines or 6 machines. I said, "This little box is going to cost more than all my machines, my pulverizer, my grinder. You've got to be joking." And he said, no, that's what it costs. In those days, it was £8,500 all those years ago, 8,500 pounds. But I went on a mission. I went home and I said to my partners and my family, we have to get one of these things. And they all laughed at me. And they said, you've got to be joking. And so fortunately, I ended up getting hold of a material supplier, and I convinced him to buy one of these things and bring it to South Africa. And he could take it around and show all the people in South Africa what's happening in their molds, etc. Cut a long story short, he actually brought it in, took it around South Africa, and nobody was interested. They said, I bought this thing and nobody wants it. Do you want to buy it from me? And he sold it to me for half the price, 5,000 pounds, which at that time was still more expensive than just about my whole plant. But I bought it. I afforded myself it. I went and borrowed money to get it. And it changed my life. It started showing me what actually happens inside the mold. When I heard about the system and I couldn't afford it, I went home. I got myself some probes. I got myself thermometers. I stuck everything I could into the molds and I started learning about what's actually happening. But I wanted this trace, okay, which I'm going to explain to you later. Some of you have seen it. Hopefully, I'll give you some more insight to it and a whole lot of other ideas. But guys, really, we can thank Queen's University for this awesome, awesome product, which allowed us to see inside, as what I say. Even though I never had eyes inside, I could see inside. The other thing that came along at a very similar, in fact, I think it was launched the same, it was launched in Barcelona conference, the first European meeting ever. And this was another mind-boggling item. Even though I couldn't see inside with this, they had created, the guy who wrote this was a partner with Roy Crawford. Right up until a year before Roy Crawford died and passed away, I actually tried to purchase this system and link it to Templogger, my product, because I told them all those years back they should have linked Rotosim and Rotolog together so that you could actually be using this program not to simulate. You could simulate up front and then actually have it running live with live input from Templogger, or in those days Rotolog, actually showing you the operator could be standing and seeing this mold spinning in front of his eyes, and he would actually be able to see what's happening, where the polymer is starting to stick. And if it wasn't sticking where he thought it should stick, or if he wanted it thicker, he could make real-time adjustments. Now I'm going to start the first video, and I hope they work. So let's see. This is a simulation that I just did. That's your mold spinning. You've got all these settings on the side. It's very complicated. I see on my screen it's running nice and smooth, and on the go-to meeting it looks like it's quite jerky. Is that correct? Is it jerking or is it running smooth? Can somebody confirm? Anybody confirm for me? Is it running smoothly? Is it running smoothly anyway? Okay, so now there's the polymer sticking. The polymer starting to stick. Okay, now you can see in each, what you do is you import a grid, which you can generate in most CAD files, of your actual product from the drawing of the product into the program. You then give it your machine settings. You're spinning at this RPM. This, as you can see, is a rock and roll with a 5,000 liter. So it's just doing the rock. There's the rock, and it's rolling at the same time. And I've just shown it in some slow speeds and high speeds because I'm going to go back and walk through this one again. What happens, what we found, without being able to see into the mold, the one thing that this did for me, it opened my eyes that if I spin quickly, the faster I spin and the faster I rock, the more evenly I cover the mold. So even though I couldn't see into my mold still at this stage, I could predict what was going to happen in a simulation, and then I could go and try it, and we'd run it. We would actually run for when we estimated when it was the polymer was starting to stick to the mold, according to Roto would say at about 10 minutes, you've actually got product sticking there. You can see now, it's just, by the way, I'm just going to keep referring to the video. Now it's rolling in one direction. Some people call this a dwell. They go, if you notice beforehand, we were just rocking and rolling. Now most of the world dwells. They stop in a position, and a lot of Indian companies do not dwell. I do not like the dwell. And also your cooling. A lot of people will rock and roll while cooling, and yet in the cooling stage is when you don't want to rock and roll. Okay, so I'll just let this run again while I continue to talk about it. That line that's running on the screen, there's a white line running there. That is the estimation of where your powder is sitting, for those of you who are not familiar with Roto. In other words, if you look at inside the mold, the powder is lying just at the bottom of the mold, okay, 90% of the time, okay. And when the powder is lying at the bottom of the mold, and we heat the mold, and it rotates, away from the flames, it starts cooling down. And we've actually done tests where we can show that the mold is heated up as it passes, especially over open flame. Well, in specific over open flame. And then when it goes away from the flame, if you're rotating too slowly, you will find the mold surface actually cools down, and then you heat it up again, cool down and heat it up. This is not good for our process, for time, for quality, for nothing. So playing with this tool, I was coming the closest I could to actually understanding what was happening inside the mold. But keeping in mind, still never had eyes inside the mold. So great tool. I got them, I was one of the developers. I never ever paid for this program because I was considered a development molder. I used to give them feedback, what's wrong, what's right, what works, what isn't working. Even today, I get demo units from them and I'd run them. Must ask for an update. There is another program that's come on from a German university, but they're not selling it, which looks very good, more realistic looking. But Roto for the average person in the field can help you. And it would be very interesting to know who's got Roto. Okay, what you'll see now is you can see on the actual tank, there are different colors. Now, the different colors are represented by different wall thicknesses. Now, this test we did very funny and very strangely. We just spun it at funny speeds and things just to get unevenness, to show people. Because if we coated this perfectly, it wouldn't actually show up. So in this case, while it was running, I did some crazy settings. And as you can see, there's areas that are gray, areas that are red, areas that are yellow. Now, if you look at the bar on the right-hand side of the picture, it actually shows you at what, more or less, what the melt thickness was. Okay, so if it was yellow, it was 6 molds. If it was still gray, it had no material there at all. So just to give you an idea, so it is a pretty good indicator. If anybody wants to know something about what they're doing inside the mold or learn a little bit more, a good tool. I don't sell it. I should become the agent, but I wish I had owned this program and linked it to 10 bloggers so we could actually really get benefits from it. But anyway, so that was another great tool. Now, both these tools have been in the industry for over 25 years, almost 30 years, both of them. Now, I have an issue yet. I don't know how, there we go. Okay, couldn't get to the next step. Another eye-opener for me is I'd heard about a guy, Rodney Styler, in America, who had actually developed a little system where you could put a little video recorder inside a mold. Something I tried and I damaged about 3 cameras. In fact, the last one I damaged was in South America. It was not in Anthony, who's with us today. In fact, it was in Chile. And after damaging about I think it was almost 6 cameras, I decided to give up with it. But I found these videos years and years ago, and Rodney did us a great favor of showing us some things, what's actually happening inside the mold. Unfortunately, not enough work was done on it. I would have loved to have gone further, and still someday I might even hopefully get to take this whole experience to another level. But when I sold my company, I stopped. What I realized is I actually stopped playing in my factory. Now, sorry, I don't know. My phone's making funny noises here. I don't know what's going on with it. Sorry. What happened is when I owned my own factory, I started Roto Solutions, I had the privilege of playing, designing something, putting it in the machine, experimenting with the frame, with the molds, with the wall thicknesses, with textures, with everything I want to do, and see what actually the result was inside. Today, unfortunately, the only time I get to play is sometimes when I'm in factories who can and have the equipment for me to play. But other than that, my playing and developing has actually come to a little bit of a grinding halt. I must say, look, I've done some amazing things in factories. But yeah, what I'm going to show you now is also very old, but I've not seen better. I have some videos of my own, which I didn't manage to find. I don't know where they are, of open molds where we could show you more of what's happening inside, but I'm going to show you 1 or 2 to start with. Okay. Okay, to see some of the things inside helped us with our measure, control, and improve slogan and aim in life. Because everything we found that gave us some insight as to what is actually happening in the process and in the mold, obviously helped us every time we opened. I think I said it just now. Yes, I did. What we would do is, like with Roto, we would actually predict what to do. Then we would run a product, and if Roto said to us, at 10 minutes you're going to have a 1 millimeter wall, we would, and fortunately we had very, very quick releases on our molds that we could open them very quickly. We would, at 1 minute, we'd whip the mold out of the oven and whip the lid open and ruin the part, but see if Roto was actually giving us the real scenario. So maybe I should just go back a second there. And I don't know if I spent enough time on this, because we never had any idea what was happening inside. Is happening now. I can't go back to the video. I don't know. Yeah. When Roto tells you something's happening, okay, and it's predicted that this is what would be happening, we would run this. We would actually put this on the PC next to the machine, even though it wasn't real live. We'd watch it and we'd say, okay, it says this is what's happening, and we'd stop the machine, whip it open, and have a look inside to see if it was correct. And then we'd play with settings, and we'd play with settings in Roto and open the mold at different times to see how real we could get it. So I wasted hundreds of tanks, tons of material trying to prove what's happening inside the mold. And yes, we got it very, very close. We got it extremely close to the real thing. I don't know if any of you have ever tried that. Just stop the mold at a certain time. Because you're going to see later on, when I come to my real pride and joy, temp logger, we did the same thing. When the graph said this is what's happening, bang, we opened the mold and did it. So you can look in with your torch, but you can't really see what's happening. The torch is such a small insight into the mold, and I'm going to explain to you why just later on, but let me go back here. So this was the next thing that gave us quite a bit of insight into what's happening in the mold. Okay, the flow in what you've got to keep in mind when you're watching these videos is the camera is fixed inside the mold, so it's a little bit confusing to most people when they see it for the first time, because you would, if you're standing looking in with a torch, the mold is spinning and you standing stationary. But now the camera is actually moving with the mold. So let me just start this video. I hope it starts. Yeah, there you go. Okay. In this case, this is the first video, and in this case, the camera was stationary, looking into the mold. Okay, with a triangular with different colors in the base, just to give you an idea of what is in what position. Now, later on, I'm going to show you real-time videos in the machine. As you can see, for those of you who know what's and can understand what I'm saying here, if you were in the beginning of the video, you saw the point sticking very far out of the material, and now it gets deeper and deeper into the material. That is obviously the angle of the mold. The mold's going further down and up and down, up and down. Okay, so it's a very I don't know. This is very, very difficult. I can't get any feedback if anybody understands what I'm saying. So I'm just going to have to push on. But it's yeah, talking to myself is very, very strange for me. All right. But what if you notice there in the beginning of the video, the points were sticking out of the powder, quite far out of the powder, and then eventually the powder sort of got up to the top and eventually covered over it. That is because, obviously, take for example, in this case, this was a rock and roll. It's going down, 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 and then coming back up, up, up. But it is turning very slowly, just for the benefit of the video. This would never be this slow in real life, because you would never mold anything if you took this slow. You can see there's the powder. It's obviously the mold going down, 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 so the powder goes over the top. Okay, the flow of the material goes over the top and covers the part, and as it comes up again, goes out. Now this is the centering part. Now the interesting thing for me in this video, more than the actual mold and everything else, is if you look at the flow of the material. If you look at the flow of the material, okay, the only way I can do this is go back and start it again. Look at the flow of the material. This was, for me, nobody was actually even looking at this. Everybody was looking at the mold. Everybody was trying to prove what happens when you rock and roll and when you go. And by the way, something I should mention, if any of you picked it up, is a forward, and then at some stage it reverses. So you have to forward reverse when you've got steps. What do you call them? What do you guys? There's ribs on the top of your tanks with these massive ribs and ears and things. You have to forward reverse, otherwise you will not get cover on both sides equally. And another issue that was proven here with is if you go too long in the one direction, you run out of powder, because now there's enough powder to cover the mold. And if you go back reverse and you've used most of your powder, you won't get cover on the other side. But the point I'm trying to make now, for me, and everybody is blown away that I was sitting looking at the powder. The powder is not flowing. It's what I call tumbling. And I said to him, why does your powder tumble? Because I had played with open molds, not inside the oven, rotating open molds just to see how my powder flowed. And there's your reverse, by the way. Now it's going in the opposite direction, for those who, any of you have noticed. Okay, so that's your forward reverse coming into play. But what I'm saying is, look at that powder. It sort of climbs up the side and then drops. Climbs up the side and drops. Now this feature is actually even built into Roto Sim. They call it, what's the feature they call it in Roto Sim? They've even got a name for it. They allow for how the powder climbs up the wall. And I said to them, but guys, why is it climbing up the wall? It should climb up the wall, but it shouldn't. If you see what I'm saying, it climbs and then drops, climbs and then drops. It should be flowing. If you put water in there and you turn it, doesn't matter. The faster you turn it, the water will start climbing up the side, but it won't drop. It'll just flow up and cover evenly. And in those days, the early days, in the early 80s, I was telling people you're doing it wrong. And what I realized is I had a better grind than most, which I will address later as well. But while I'm at each video, I feel I must just spend some time explaining to you what I'm seeing, because we can keep going back, but I don't think, you know, time goes quite quickly. I see we're already almost 8:30, and there's quite a bit to get through. So it would be very nice to know who's with me, who understands me. Unfortunately, that I can't get. So from looking at sharp corners like that, the way the material flows, we found out the mold design is very, very important. And I've already mentioned it, ribs are not good for flow. It ruins everything. Too many people in the world, in our industry, people just love to put ribs into products, into tanks, water tanks, below ground tanks, everything. We need to make this stronger. We need to stiffen this up. In my opinion, a pile of poo. That's the kindest and nicest way I can put it. A pile of poo. Okay, ribs are our enemy. I'm sure I've told you all in plenty of presentations, the two biggest court cases in the world, which is millions and millions of pounds, were lost. Both Roto Malters lost their cases for millions and millions of pounds. 4 years in court because they had ribs and they never had process control. So they put ribs in thinking, great, to stiffen it up. They didn't know what was happening in the molds. They didn't get the design right of the ribs. They didn't get anything right, and they lost millions and millions. I'm surprised, and the only reason they both survived was they're both two huge, huge companies. I'm not going to bring them up here again. It's pretty well documented in all the journals what happened. But ribs are not good for us. It ruins that flow, and it creates problems. Try having big radiuses and big curves. Even on a box that should be a square box, even on a square box, I was called into Holland about 5, 6 years ago. They were starting with the robots. I'm not going to talk about robots today, but they were using the best machines in the world, the best molds. They were using CNC top range molds. They were using robots to mold these pots and things, and they wanted flat sides. They could not get it flat. And with a few little tricks, looking at design of mold, we actually managed to get them perfectly finished parts. And today I'm not allowed even back in that factory. They won't let anybody back in the factory now that it's all running perfectly, and they bought more machines, put more molds in. I'm sworn to secrecy and signed non-disclosure agreements. So I cannot tell you what I did there, but nobody will ever see what they did there, and they're one of the top pot plant manufacturers in Europe. And it was all I can tell you. It was the basics, yeah. It was the basics about sharp corners, flats, curves, and flow. Okay, you don't want to have problems with flow of material in the mold. If you have problems with flow of material in the mold, difficult again. Normally I would hold up something and show you, but try and imagine what I'm saying now. If you take your phone or anything square and you tilt it at 45 degrees and you put powder in the bottom of that 45 degrees, okay, in the bottom of that mold, and then try and visualize this. I should have tried to do a little video of it. I just don't have time. It will take me hours and hours and hours to present something like it. But if you take your phone, like I've got, I don't know if you can see it, okay? And imagine there's powder in the bottom here. Actually, I've got a bottle here, okay? Can you, anybody, I hope you can see that. And you're spinning like this. Now, if your powder's bad and you get to a point and the material, this is liquid in here, unfortunately, so it will flow, and that's what we wanted. Like when I said earlier, when I looked at that material tumbling, it doesn't matter how fast I turn this bottle, I've got to get this reversed. No matter how fast I turn this bottle, it'll flow in here. Okay, so okay, you can all see me, eh? Can somebody verify me? You can see me? Hello?
It's okay. Yeah.
Yeah, I can, Gary.
Okay.
Yeah, and now I got to turn, and I tip it. The water will run immediately, flat out. But powder doesn't. It builds up. Got it in the wrong. Builds up, builds up, builds up, and it'll sit in that corner, and it's sitting in the corner, and then eventually it will just zoom right across to the bottom, not giving it time to stick to the middle. So if you do it on a square, and the pyram is sitting here, it will sit there, and as you're turning like this, it'll sit there, and then it'll run down to here. And this is why we get thinning on the flat spots, and why we get uneven walls, buckling and warping. It's not to do with the shape of the part. It's the process. So what we've got to do is control how if we can get the material to flow nice and even right along here, and then slowly down to there, and keep going steadily all the way around as we spin and turn, you will get a nice even wall thickness. And that's the basics of what I'm trying to say here. So, but now when you get a rib, if this is your rib on your part, the material falls into the rib, okay? And then when you turn, it sits there, and it falls out of the rib. And if you're only going the one way, the material doesn't actually sit on this. I don't know if I'm doing this back. The material doesn't sit here. It falls in, and it sits on this side, and it lies here until it falls out. Okay. So now you've got to turn. This is why you've got to do forward reverse. You go back, falls in, goes to the side and out. So what I'm saying is, these things we learn from these videos. Now, I don't have all the videos. I can't find every video that we ever did, but I'm going to show you some here. So what we saw clearly is that a rib is a big issue in our process, a huge issue in our process. Another issue, kiss-offs. A lot of people put kiss-offs into pallets, into double skin parts, surfboards, panels, to keep them stiff and rigid and give it strength. This is going to it's just an insight to showing you this is not a really great rib kiss-off design. But if you can keep in mind your shape, if you've done kiss-offs in the past, when you see this video running, and what happens here is the rule of thumb, the gap between the two the two kiss-off parts that you want to kiss off should be maximum 1.5 times wall thickness. Gap between the two kiss-offs, 1.5 times wall thickness. Okay, because if you go more than that, you're going to have this issue that you're going to see now, or you're going to, if you're closer, you're going to have bridging, and you'll have holes and all sorts of other problems. Thin spot. People show me all the time, I've got a thin problem. I'm trying to thicken up here, but it's actually thinner. It's all about design. So now let's see if this, now again, very confusing. If you look at remember, keep in mind now the camera's stationary in the mold, and that's why it looks like the powder comes running past every now and then, but it does. It goes down to the one end of the mold. The powder's running around in the mold, and then it eventually comes back here. But the point here is, watch. It looked like they were building up a very nice kiss-off, okay, and it was, but the gap is too big. Okay, so because the gap is too big, as you start sintering, you start seeing what happens. Okay, now all the powder is finished. So now when there's lots of powder, it's still your parts thick. But as you start sintering, it actually thins down. And because it's now your density, you're getting rid of bubbles, you're getting rid of all the air, and you're melting. And as you can see, the two parts start pulling away from each other. They're not actually pulling away from each other. It almost looks like they're pulling away from each other, but they're not. The powder is actually sintering, curing, and because it's curing, the density, it's coming to its correct density, and now it leaves what we call bridging. That is not a kiss-off, that's a bridge, and a very bad bridge at that. So you won't have strength, you could actually have failures there. Now, for me, it's extremely interesting, and it changed a lot of my way of thinking about ribs. And we played, and we've got multiple types of kiss-offs. Yeah, there's one design that really works specifically well, but can't always be used in all applications. But I hope you're seeing the message I'm trying to get to you is flow of material. If you don't have enough material, you won't even get it onto the top of that rib, which kiss-off, which we find in a lot of cases. People make kiss-off so deep into molds that they don't even get material to flow over it, so it doesn't even get to this position. But this is assuming, and I hate the word assume, as you all know if you've been in my presentations, is we're assuming that they've got enough material in the molds to cover the kiss-off. But over time, actually pulls away, and you see these little white connectors. You've got 3 or 4 little hairs connecting the two. So the first knock it takes, they break, and you don't have a kiss-off. I hope that point came across clearly. Anybody? Very, very strange talking to myself. Hey.
Very good, Gary. Carry on. It's very good.
Now it's going to take a lot for me to get used to this webinaring because, yeah.
We all are watching. It's very good. We have more than 100 people here.
Okay, it would be so nice to hear people and see people. I like the interaction, and it's just not getting anything here. But anyway, so really, I'm finding this quite a challenge, to be honest. But anyway, it might be as
किसी को question हो कुछ doubt हो तो please पूछ लें. Please ask any question if you have any doubts or you want clarification. Gary feels more comfortable if we interact than if we just keep speaking. He doesn't know how much is being absorbed.
Yeah.
Okay, I am getting questions. I will ask in open house.
Who is that now?
Yeah, you can ask in open house. But Manoj, you can ask in between also. So Gary is sure that message is getting across. Some questions you can.
Okay.
What I would actually prefer is if you stop me every few minutes and give me 1 or 2 questions, let me address them now, and then we carry on, because yeah, I mean, I can talk for 3 hours and we won't have time to get finished, but we only have 2 hours. So maybe if you've got 1 or 2 questions, do you want to shoot them?
Yeah, okay, Gary, I have one question from Mr. Jamshed Thodiwala. He is asking how to avoid porosity in manhole square threads.
The porosity in?
Manhole square threads. Mr. Jamshed, are you in group? Mr. Thodiwala?
Okay. Just one thing we've got to be careful here, okay? That question could actually wait till the end. Because we haven't got to that part. What I'm saying is, I would like questions, if you stop me on questions during, if it's something I've spoken about. But I'm going to address that one now, but that one will probably be answered as we go. What happens is, when you've got threads, the biggest problem with threads is wherever you've got a thread, they normally have a secondary flange. They'll have a thick machined part, There's a number of things that can be the problem. If the part is machined, it's normally thicker than the actual mold. If you've got extra flanges, which you normally have to have, you have to have an extra flange because you want to turn that part off before demolding. All these thick parts, flanges, will draw the heat out of the mold. Okay. Now, if you go back to the flow, okay, if you go back to the flow, I'm not going to go back to the first one. What you see is in the beginning, all the fine powder sticks to the mold first. And if you watch this whole video, which I didn't put the whole video, we don't have time for our videos, you would have seen that all the fine powder sticks first to the mold. And now what's running around at the end is the thick, bigger parts. Now, what happens is where you got a parasite mold, what I call a parasite mold, which is a mold sitting on a mold, like that little end cap, with a lot of steel on it, a thicker metal, it's going to take longer to heat up. So 99% of the time, by the time the part where you want the thread to form, by the time that gets hot, all the powder stuck on the rest of the mold. Okay, so the only way to address that, and you see people doing it, they preheat with torches and they do all sorts of crazy things. Now, I can't spend too much time on that, but we have a number of tricks that we do with people, and people can contact me afterwards. If they're existing customers, I'm sure to help them for nothing. If it's not existing clients, I don't just give away too much free information when it comes to technical components, but the goal and what the client must look at, whoever's asking the question, is you've got to get that part to heat first. Okay. The objective is to, where you've got a thread, it must heat up first, so that when the powder comes past, the fine powder is caught and molds, not the end of the process when you've got only the big particle sizes. Do you understand? Sorry?
Yeah.
Okay, you get the point. In the beginning of the process, the first thing that gets hot, imagine if you've got two halves of a ball, okay? And the one half in the ball is 1 millimeter thick in the mold, and the other half is 2 millimeters thick. And you mold it. Guess what? The 1 millimeter part, when you cut it open, will be thicker than the other part. So it's that simple. You need to, because all the fines will start sticking first on it, and you'll have no pinoling on the side that's thin, and the other half you'll have pinoling. That's the simplest way to explain it.
Okay, thanks, sir.
Okay, another question?
I have one more question from Jeevan Nakum. He is from Nigeria. He asked one question that is there any global success story about polyamide or metallocene parts, roto molding parts? He is asking question polyamide and metallocene based roto molding products. He is asking.
Yes, yeah, of course there is. Yeah. But that one's completely off the subject here. So that kind of question, guys, must come to me privately. I'll give my contact details. You know, we're talking about what's happening inside the mold now. Now we're starting to talk about special polymers. If I get into these questions, we'll never cover what I need to cover. So I think if you get questions like that that are really random and totally off the topic, those you must just get them to either contact me or send them to me with contacts or something. But yeah, guys, if I can just ask everybody, please, questions must be addressed to what is happening inside the mold. Now, the first question would be answered sort of down the line with powder and stuff. The second question is totally off the subject. So I just feel we have to cut off somewhere. Am I correct?
Okay, one more question from Sir Blaise Kostavir. I think Blaise is in online. Blaise, you can ask directly.
Blaise.
Hello, Blaise.
Gary, good morning.
Good morning, guys. How are you?
Can you hear me?
It was very bad, but try again.
It's regarding kiss-offs.
Yeah.
Is there an ideal shape, like a cone?
Yes, Blaze, there is. We have some. We do design for people. I'm sure you all know I do design of molds. I do mold making. We do all sorts of services. Okay. And yes, we've come up. When a guy wants a rib, we have what we think is the perfect rib, even though I don't like ribs. When it comes to kiss-offs, we think we've got what is considered the perfect rib kiss-off. But again, it will depend on the shape of the part, the depth of the part. The question you're asking is, yes, there are perfect shapes, but it depends on the shape of the mold. Depends on the amount of powder in the mold. Are you is the mold fully packed when you start, or is it a big hollow component where you only got 10% of the mold filled with powder? You've got to take all these little things into account when designing for these specifics. Okay, because as you see in this one, as you see in this one, if they put more powder into this part, they would solve that problem. Okay, you see where it pulled away right at the end. The simple way to solve that problem is put more powder in. But do you want to thicken up your part because you've got a bad design? No, you've got to change the design. You see, so we have to look at the whole thing in its entirety. I will only give a guy an answer if I see the part and I see the drawing and I see what you're trying to achieve. And I will give you my ideas as to what is really correct. Does that answer your question?
In a way, yes.
Yeah.
Is there an ideal gap, in a way to calculate the ideal gap in the kiss-offs, between the kiss-offs?
Yeah, that I gave to you. That's no secret. Well, it's part of design, but 1.5 times wall thickness. But remember, the biggest thing where people make a mistake is 1.5 times the wall thickness where the kiss-off is, not of the side walls of the tank. If your side wall is 4 millimeter and you've got a deep kiss-off, it might only be 2 millimeters. So that's a little pointer, a very good pointer, which I don't normally give over open seminars, but your gap is 1.5 times wall thickness, but at the point of the kiss-off, not anywhere else in the mold. Get that one?
Thank you.
Again.
Gary, one more question from Venkat. Venkat, please.
Yeah.
Venkat.
Hi, Gary.
Venkat, how are you, man?
I'm good. How are you? Nice to see you, friend. So
Yeah,
the question is, you said the ribs are enemy to rotomolding. So who are the friends?
The friends is proper design. Okay. 99% of the time, we would just put a little bit of design into the part, and or multi-layer. You know, when it's below ground, it's much easier and far more controllable. People say foaming and 3 layers is difficult. I've shown you videos in previous Roma conferences where we've got clients doing up to 7 layers, which is crazy. But 3 layers is very easy to mold if you know what you're doing and you don't have ribs. Okay, if you have ribs and you try and do multiple layers, and that's even the worst thing when you do ribs in multi-layers, because then it actually becomes a bigger nightmare. So yeah, a bit of design, shape, and if that doesn't solve it, then we talk about multi-layer. Foaming in specific to get, you can go 2-layer, and if you really need it, you can go 3-layer. But when I say a rib, there are ribs and there's ribs, if you know what I mean. Okay, some people want a rib because the client wants to see a rib. He just wants to see it. So we'll design the ribbing, but it won't be a typical Indian rib, which is 90 degrees and very deep. So yeah, again, the same as what I'm saying to Blaze, depends on the part, depends on the shape. I mean, I'm busy doing designs right now. What I'm keeping myself very busy with while I'm sitting at home is designs. I'm doing designs for Thailand, for Europe. I've got a possible new design now for India. And we just take, when you do a drawing, send it to me. I'll look at it and I'll say no, 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 or yes, yes, yes. And if it's no, 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 I'll tell you what I can do for you. But I need to see the product before I can really comment. But try and stay away from a rib. And if you have to have a rib, it's the kind of rib, the shape of the rib is very, very important.
So, in your opinion, a follow-up question, in your opinion, ribs do not actually contribute anything to the strength of the part or the rigidity of the part or the stiffness of the part in that region. Is that what you say?
No, a rib will always give thickness, strength, okay, if you can mold the rib properly.
Okay.
If we can mold the ribs properly, okay. Now, I don't have this in my presentation, but I wish I had that part here. No, hang on, maybe, no, I don't know how I'm going to pull something into my presentation now. I'm going to mess up the... I'm sure all of you have seen that sample that I handed around and pass around in my seminars and my workshops. I'll
Okay.
the rib and say there's 24 things wrong with it. If you can remember that,
I do remember
that rib shows you 24 things wrong on one part, and the customer thought he was molding properly. So I can give you the solution to every one of the 24 problems, but I need to know what I can. You might accept 20 of the solutions and not all 24 because you want this. So again, we design and we develop according to what the client will accept. Okay, and we will warn him if he wants something that we are against, like a 90-degree rib. If you take 90% of Indian water tanks, the ribs on the top of the water tank, you do not need those ribs. I'll show you, and you've seen it in Australia. They're making up to 43,000 litre without a single rib in it. No problem.
Okay, I know that.
So why do we put ribs in? Why do you guys put ribs in when they don't? Ribs cost you material, costs you more to make the mold, and it costs you lots of failures. So I'm a very anti-rib guy, anti-rib.
Thanks, Gary.
Okay, all right. Anything else? How are we for time? What time are we finishing? Sorry?
You can continue.
Hello.
Okay.
Hello.
Yeah,
Hello.
somebody, yeah?
Hi, sir. I am Malinath. My problem is when we complete the roto molding, after roto molding we are going to winding. After winding, when we cure in the oven, at that time we found the flatness. Why is this happening?
That question is very.
I think it means that they're rewinding afterwards, probably fiber or something afterwards, and at that time it is flattening when they put it in the oven. I guess it's a round shape. They were wound down, and when they put it in the oven to gel the fiber or whatever, at that time it flattens, the round surface flattens. I think that's what it means.
Yeah, but what, Lowell, you see, I understand the question. The problem now, okay, is I don't know what the shape of the part is. I don't know what machine they're using. I can't see the mold. I can't see the frame. I don't know the airflow in the oven. I don't know anything. This is how long is a piece of string? Yes, for those of you who don't know, there is an answer to how long is a piece of string, but you need to know the facts. Okay, so this is one I will not answer on an open session like this because there's far too many things. If I say something now and then they go away and it doesn't work, it's because I didn't have the facts. So this is not a simple question. The simplest question, the simplest and the best answer I can give you is you've got to have even heating, even airflow everywhere on the mold. Now, I guarantee you they don't have that. Okay, so if the client wants to send me information, photos of the mold, the machine, I mean, is it an open flame machine? Is it a closed oven? Yeah, there's too many things. And then, yeah, that's too big a question to answer without facts.
I think you're right. You may need more details, but it seems to be a post-rotomolding operation after winding.
Closed?
Okay. Hello, sir. Another question is that. Hello.
Yeah.
Hello. Sir, another
Yes.
question is, at the time of rotomolding, after rotomolding, we found that some of the vessels are in triangular shape. Some of the vessel only. Why?
Some of the vessels are in what shape?
A triangular type. In normally, we can see easily, but it is not a triangular exact, but it normally it looks a triangular type.
Yeah.
It's a round part that becomes triangular, you mean?
Triangular means it looks triangular, but it is not exactly triangular, but it looks like that.
Yeah. Anyway, sorry, I don't know. The guys got to understand again. I'm talking about what's happening inside the mold. Let me finish these kind of questions. If I've got time at the end, I'll do it, because they're not really related right now to, if they pay attention to what I'm saying about the flow of the material, the even heating, are they curing properly? Is their powder flowing properly? 90% of these problems will go away. Again, 90%. But there's a big factors that we don't know sitting here, and unless they show me it, I can't give them. Is the type of oven, the frames, the wall thickness, the rotation speeds, forward, reverse. I'm going to ask questions to be able to give you an answer. You know, that's what I do. I can't say, okay, some parts go in and they're like this and others don't. Guaranteed, as I said earlier, I'm amazed how well some operators can get consistency, okay, and others can't, because some guys just have a better knack. But in the same factory on two different shifts, I see two operators cannot, one operator makes good parts, the other one doesn't. And it can be, remember, when we get to the graph, and I need to get to the graph to start explaining some things to these guys, is if you don't have an idea what you're doing and you're looking with torches, you are in the dark. Okay. So I think we're going to stop questions and let's move on, because I see it's what time. How long have we got to still go? That's what I need to know. I'm happy to continue over, but officially I think we got a half an hour. Is that correct?
Yeah, we have only half an hour's time to complete.
Okay. Listen, let's move forward.
You could do something on the temp logger.
Sorry?
You could do something on the temp logger.
Yes, Lal, let me continue. I'm going to just step it up a bit, because there's so much. I'm talking on what's happening in the mold, and that temp log is one of the things. All these other things I'm showing you are vital as well. So let me move on. And then at the end, if I'm happy to stay online if one or two people want to ask questions, but they're going to have to give me some answers to be able to help them. You can't just say one part comes out looking good, another part comes out looking triangular. First of all, what's the shape we start with? What's the process? What's the cycle times? What's the material? What's the density? What's the, blah, 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 blah. So, okay, let me just move on here. Okay, guys, are you happy? Can I move on?
Go ahead, Gary.
Okay, because right here, if you look right now, this is the next step what I've just been telling you. Design of the frame, the spiders, very important. I'm just being, you see what I'm saying? The guys are coming with questions ahead of where I'm going to. The frame on the mold can affect the part. The spider, if it interferes with the airflow, can affect the part and what's happening inside. Okay, keeping in mind everything I'm thinking of, these can affect the powder buildup on the surface of the mold. Okay, so now just as short, a little, the next video here, okay, it will give you some idea. If you look there in the middle is the parting line, okay, and you can see clearly the parting line. But why can you see the parting line? The reason you can see the parting line is because there's a flange there. And the flange, if you look everywhere in the end corners of the picture here, you'll see when the video starts running, the material sticking in other places are not here because the flange is delaying the heating up of that area, so you get a thinning inside the mold. Okay. Now this is typically what I'm talking about. If the part was hot and the material flowed over it, it would stick there. But because the material flows over parts and it's cold, when the material comes, it doesn't get to stick there. Okay. So these are the kind of things I'm talking about with the previous questions from even Blaze, even your kiss-off. If your kiss-off is deep, a deep pocket, and doesn't heat up, when the material comes there, it won't stick. And that's why kiss-offs are normally thinner than, because they insert, they're deep pockets that don't heat up. If you look at mouse, they sell a thing called what's it called now? Come on, a heat stick or whatever they call the damn thing, to get the heat into pockets and things. So if you can get the heat onto the flange, this is why people use flames on flanges and things. They try and preheat the flanges so that they get thickening. In India, a very common problem, and you'll see it in this video if you can understand the video, is you do a lot of double wall black and white or something, and often you see the inside color coming out at the flanges. And the reason is because the flanges take longer to heat up, so there's no black sticks there, and when you put the white in, the white sticks. So yeah, okay, I hope you guys get these points. Difficult to, but that line in the middle there, it's still there because the flanges delayed the heat up, and when the powder came, it did not cover it. Okay, so very important. A lot of people online here, I know, I can see some faces of people here who have walked into their factories and just said, cut the flanges, drill holes in the flanges, remove the flanges. You got it all wrong. Okay, especially with your stainless steel molds. When you got a stainless steel mold and you got a 12 mm flange, and it's a 2 12 mm flanges, that's 24 millimeters of stainless steel that doesn't like to be heated up, sitting at a parting line, it will delay the heat getting into that area and will affect what is happening inside the mold, the powder buildup. Again, the next point, this is covering that threads and again, not only threads, it covers, this is your kiss-offs, it's your pinholing, it's ebbing, powder. If your powder isn't right, as I showed you in the first video, the powder it's not flowing, okay? The powder is not flowing here in this first video. Is it this one? Yeah. The powder is building up. Oh no, I don't know if I've got time to keep going back, but let's see. Yeah, if you look at this powder, it's not flowing like water, and that causes a problem. Again, this should be flowing like the water I showed you in the bottle earlier. If you can get it to flow like water, you will solve a lot of your problems. So now, what we developed when I was still very active in Armo, now this won't go forward, what's happening? When I was in Armo, I said the first thing we have to do is improve our powder. Because if we have a bad powder, it affects what happens inside the mold dramatically. Dramatically. Okay, if your powder doesn't flow, it doesn't flow in the mold as you saw in that video, it climbs up the wall and drops, climbs up the wall and drops. When you got flat areas, the one client now asked, he gets triangular shapes and things like that. This can be the problem. It could be powder, it could be release agent, it could be, there's a number of things that affect it. That's why it's not easy to answer, but you have to have your powder right and your heat source right, and then understand what is happening in the molds when you spin it to be able to get a good finished part on the inside without pinholing, etc. So this standard is the first and only standard. It's the cheapest test in the world, and if you don't do it, you're already you're starting wrong. This is just quickly how you do that. This is an old video when we were developing the test. Okay, guys, that quickly is the simplest test you can do in your factory. And if you put any powder into your mold without knowing what the quality of the powder is and that you have a good powder, you are going to have thread problems, which one person has. You're going to have kiss-off problems, which another person has. You're going to have different shaped pots, flat sparkling, because it's not flowing in the mold properly. So powder is very, very, very important. This next video, I don't have time now to explain every detail. I could talk for 2 days on the subject you've given me. I've had to compress it and try and make it interesting. But this next video, if you look at it, their powder is stuck on the mold, okay, the fine powder already. Now, very few people know and realize that material can actually, this is the material moving on the mold. It's a high melt flow. It was done on purpose to have a high melt flow. Just to show you what can happen, this is a 7 melt flow, which is abnormally high for most rotomolders. And that's why we'd like to use 3 to 3.5, because otherwise you'll get this kind of effect. But the reason for this high melt flow comes back to, this is another big issue, an insert and a graphic. Okay, you can see the graphic coming through there, and shortly you'll see the insert. Now, we need the powder to get under and around that insert to create a thread, which will be there for later on to screw something into. It can also be related to your thread that you're molding. Look how watery it's getting there. The actual, in this case, the insert had been overheated, okay? So you can see around the insert, it's actually running like liquid already, where the rest is still flowing around. Now, the point I'm just trying to make here is sometimes there's things happening in the molds. If you overcure and you overheat, that you will destroy the polymer and you'll destroy the pot. And when it comes out, it could be buckled, it could be wet, it could be anything. It could be brittle, it could be whatever. So it's just another interesting, this one was done, these tests were done for other reasons, but just to give you an idea that material can actually flow in our molds, okay? So I'm not going to waste time on this. Okay, insert and overcure. That's an insert there. It's ridiculously overcured at the insert. Okay, but done on purpose, was trying to solve the problem of pinholing around the insert but everything that is done in this video was done for the wrong reason. And later on, all we did was got the powder right and the insert to heat up faster, and problem solved. What I've been saying earlier. So a lot of people chase in the wrong direction, and I'm just showing you, we didn't always get it right first time. We did, until we understood what was happening in the molds and had more insight, we could actually start doing something to change it. And that is why here's another showing the cooling process. The polymer, when it's really molten, as you saw in the beginning, is almost transparent. This is the infrared camera taking the actual, showing the different heat scales in the camera around the inserts and things. And then as it cools down, you see it goes from a clear product to a baked product. And then you can actually watch how it delaminates off the mold and where it's sticking to the mold, etc. Okay, so, and this is, there's a lot of talk around, do we keep it in contact with pressure to the mold surface, or do we get it out? I'm a firm believer in demolding very hot and get it out, especially in a case like this, where he's got inserts and all sorts of things, because if you leave it, and this also answers some of the questions asked, the buckling and different shapes. If you've got inserts, undercuts, and one time you overheat and overcool, the next time you heat more correctly and cool more correctly, you'll have different quality parts, different shapes, etc. So when I know what your process is, when I know what your whether you've got undercuts, whether you've got leaking flanges, a leaking flange, you all know that I say a leaking flange is one of the worst things in roto molding. It destroys products. It builds in stress. It does everything wrong. So just a leaking flange. If you've got leaking flanges, go home and you've got problems, go home and sort out the leaking flanges, and you'll solve a lot of problems. Because we soon discovered that a leaking flange is an insert, and it's holding the part where you don't want it to be held. Way back in about 2005 or 2006 in France, I walked in and I just cleaned the flanges for a guy who was having rejects and rejects and rejects. We sealed the flanges, we got them flat. He said, we're wasting the whole day on the flanges. I said, no, we're not wasting the day. The next day when we put it in, he had paid me to be there, and all I did was fix flanges. And he paid me a lot of money. But the next day, all his problems were solved. And then he looked at me and he said, Fig Jam, and he nicknamed me Fig Jam. And I won't repeat what that means, but I got this nickname around the world because it's Flip. I'll say, Flip, I'm good. Just ask me. That's what Fig Jam stands for. I solved all his problems just by cleaning the flanges. Okay. And and took his temperature. Anyway, here's another one that's interesting to India. In specific, it's an open flame. If you look at that video, unfortunately, it's very noisy. I can't talk while it's in. If you're spinning, too many machines do not go down far enough. Rock and rolls between 30 and 36 degrees. You're going to see the difference. That first one is 30 degrees. Okay, and you can see it doesn't even cover the base properly. The material doesn't get to the middle of the mold properly, okay? And then if you put more material in, it will cover to the middle. But during the process, as it's laying up, you will lose material, and then you'll end up with thinner spots. So angle is very important. Here's a 36 degree, same machine. Oops, what's going on here now? Now I'm seeing the sound and not the video. Why is that happened? I don't believe this. What's happened to this video? So yes, I tested and checked this video over and over and over. Okay, by tilting the machine a little bit further, you get a perfect scenario, okay, a solution. Okay, when I started rotomolding way back in 1979, I'd worked out that 60 degrees was the absolute minimum. And today, 95% of rock and roll machines in the world do not go past 45 degrees. And they're lucky to get there. We had a machine at one stage. This is called our Rock and Roll 360. This machine normally rocks to 85 degrees on a rock, both sides, 85, and it can also do 360 degrees when required. So yeah, 85 degrees was our standard. By 2004, we never had a machine that didn't go down to 85 degrees. And no dwelling, which solved a lot of problems. And it's only because we looked inside the molds to see what was happening that made us do these things. And then rotation speeds, another thing. The faster you spin, the better the heat transfer. But if you don't rock to the right angles and spin fast, you create problems. Now let's say these videos work. Okay, again now, if you look at a video like this, they've got ribs in the bottom to try and help them scoop the material into the middle. Where in actual fact, you can just tilt the oven a little bit more. Now, why is every second video not working? There's something really strange going on here. I don't know, sorry guys, I tested this last night again and it all worked. Oh dear, I don't know what is going on here now. But if you tilt the machine 5 to 6 degrees, you can get a completely different result. Okay, so angles, tilts, and rock and rolls. I love rock and roll machines. I love rock and roll machines. But if they're wrong, if they're open flame, they're wrong. If they tilt to 30 degrees, they're wrong. If they rotate slowly and they don't forward reverse, they are wrong. So there's right and there's wrong. I showed you a short clip of one of our machines that we developed years and years ago, and it is a master. I call it the dream machine. It can do anything. It can do anything any machine can do, okay? And it's a rock and roll. But if you've got the wrong rock and roll, stay far away from it, in my opinion. Okay, what happens on the outside of the mold has a massive influence of what happens on the inside. I'm just going to speed up a bit now because I'm running out of time. As always with me, unfortunately, on what happens on the inside of the mold. So we've got to pay attention to the outside, like the frame, like the spiders, like everything. With an infrared camera, you can have a look at a very, very popular error, not popular, a huge error that most people make. They put too many molds onto an arm thinking if I put more on, I get a better conversion rate. Wrong. It's better to put less on and keep spinning flat out, get even wall thicknesses and do it correctly. We produce faster than anybody I've ever seen in the world. And I think I've been to, I keep saying over 500. I can comfortably say probably over 600 rotomolding plants in the world, from the biggest and the best and the fastest in every country to the smallest, the meanest and the leanest. And I've never seen anybody produce as fast as we did in our machines. Reinhardt, who's on here, has got a super fast, and they advertise very fast. They fast, yes. But we were, in my day, nobody came near us. And fast is good, but if it's all wrong like this, okay, it's going to cause you more problems because you can't get the airflow around the part. So if you don't get the airflow around the part on the outside, guess what? You're going to have problems on the inside. The spiders here are creating problems. afterwards, when you're cooling, on the right hand, on the left hand side when it's coming out of the oven, the right when it's going into the oven, the left hand side is when it's coming out of the oven. No, sorry, I don't know, it's wrong way around. Left hand side is when it's going into the oven, right hand side is coming out of the oven. And you can see all the different heat spots and hot and cold spots. Sorry, I'm getting a call from Virpal. Hello? Hello? Is there a problem? I'm getting a call from you guys. Virpal, is there a problem? Hello? Is there a problem?
Gary?
Yeah.
Gary, you need to complete it fast.
Yes, okay, thanks. Okay, so I'm being told I've got to complete it fast. Infrared can help a lot, okay? I'm going to jump off that. This is my most amazing tool, TempLogger, and I was really asked to give you a bit of insight into this. So I'm just going to, I've shown you Roto, I've shown you infrared. The tool that we developed was TempLogger, which is a version of Rotolog, but in my opinion, the Rolls Royce of these systems. Okay, I see I've got 10 minutes left, okay? What can be learned using the internal air? Besides PIT, which is the peak internal air. Peak internal air is a must, and we have to get there. And if you don't get there, it's going to affect the quality of your part each time. If you have different peaks, pits on each product, you will have different quality, okay? So it's important. And the trace, but the whole trace inside, the air internal trace is very important. And you've seen these graphs before, most of you, how it builds up, etc. in the mold, okay? I've just got two little different slides, a little bit different here to show you. What happens is in the oven here, on the left-hand side, you've got an actual camera checking the polymer melt while it climbs. If you watch where the arrow is and where what's happening inside the mold, as the arrow climbs up inside the mold, this is if you're getting to the right pit, because most people don't. You see what happens to the material on the left-hand side. You start getting sintering, you start getting rid of bubbles and everything as you go up, as you go up. This is how you get rid of bubbles and pinholes and all these things. But if you don't get to the correct pit, you will not get rid of these. And if you don't get rid of these, you do not have the correct quality, and you do not have the mechanical properties of the material, and you will have different shrinkages, and you will have different parts every cycle. So this is very important. This little is showing you how you actually get to cure from that point where the material starts sticking to the mold, and as you go up, how it cures the part on the way up. Again, that said, this is what's happening in the mold in the heating cycle. Very important. Okay, and I'm going to skip these because I have shown these a few times. And then you got your cooling cycle. What happens in your cooling cycle? Very important. Every step of the way will create a good part or a bad part. And sadly, I'm now being forced to run a little bit faster. But what I'm going to go to is this little part, picture here. If you look at the red flag, okay, there's lots of things I see in a graph. If you've got a graph and you've got all our machines, by the way, ran and were controlled and ran 100% by TempLogger. Okay, so we actually had a system running our machines, not the operator. The red flag shows you when the powder is actually stuck, starts sticking to the mold. Up to the green flag is when all the powder is stuck to the mold. Up to the yellow, as I showed you in the previous slides, is where you get your cure, when you actually start getting your densification, getting rid of bubbles, etc. The grey flag at the top is called PIT, peak internal air temperature. If you do not get to the correct PIT for each material, you will not get a good cure, and you will not get the same part every time. From the grey flag down to the red dot is your cooling. Now, cooling in most cases is too slow, and when it is fast, if it's uneven, you will have buckling, you will have distortion, you will have it. So you need to understand what is happening during each step of the way here. And if you have a temperature monitor or anything that resembles any kind of temperature, you can learn a lot about what is happening in the mold. I say, even though it's not eyes in the mold, this is the closest we ever will get to at this stage. One day, hopefully, we'll still have cameras inside the mold to be able to watch it. And that is one of my next goals. And then from the red dot to the green dot is where it's actually, you've gone through your crystallization and you'll see you get your break off from your mold and your shrinkage starts to happen. Now, this is always around about 125 degrees. So why do we cool right down? In this specific case, this is a client of mine, this graph, and he sent it to me, and you can see he actually opens the mold and pulls the part out at 90 degrees. This is a very good practice and will get you better quality parts, and let it cool outside. So having control, this is a 3-layer product, by the way, okay? A 3-layer product. The first, you can see the oven goes up in the oven, comes down, and we get the temperature we want for the first layer. Not too high, not too low. We then put the second layer in, and we not too high, not too low. We are just laying up the polymer. As soon as the polymer is stuck on the mold, we then introduce the second layer. But with control, we know how to do it correctly every time, within 5 degrees. Then your third layer, you put the material on. So now you've got 3 layers of polymer. One will be outside skin, the middle one here would be foam, for example, and this third layer would be your final layer. And only when you've got all 3 laid up nice and evenly on the surface of the mold, then you take it up to get to its temperature, to pure it, to be able to get a good cure. As you can see, it says at the top here, good cure. It got to, which is an excellent cure for this polymer, with 3 layers. Okay, I'm being called again. I think I have to stop now. Hello? 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 Vidbal, I don't know why it keeps cutting off, but I think it's calling me. I don't know if that's the end. Sorry, I don't know. He's sending me messages. All right, guys, I would like to spend more time on this. There are so many things you can do with temperature monitoring. It is my baby, and unfortunately, I didn't really get to it. But anybody who's interested, please contact me, and maybe I can do another webinar just on temperature control if people are interested. I think what we all have to do is let Roma know what we want to hear. And if you guys would like to hear more about temperature control or design or anything, I'm available. Just to let you know that I did a presentation recently in Norway, and we've got 3 factories up there in a little place that are totally run by Templager, 24 hours a day. Okay, CPAX, Motorola, and they're the 3 top guys in Europe. Down in New Zealand, I've got a guy who's rated as one of the best molders in the world. Okay, and he will not operate. We've just shipped him 2 more Templagers last week, and another one went yesterday. He runs everything with temperature monitoring, and it controls it 24 hours a day. He will not switch his machine on anymore without it. Then this is all blah, 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 blah. Here's my hero, Roy Crawford, who gave us Templager, awarding me a prize years and years ago. But then I just want to go right down to the end of my presentation. I'm going to skip. This is everything about temperature monitoring. And I'd just like to say to you guys, it's been awesome. Thank you for having me. It was very strange talking to myself. I would like to talk to Roma about a better platform, guys. Really, I've found through my brother, who's a webinar specialist, far better. We can have total interaction where guys, you can ask guys to vote, etc. So the speaker has an idea of what's happening, whether people are happy with what he's talking about, whether they must move on, they can vote, and all sorts of things. So I would like to talk to you about that. And then, guys, anybody who's got questions, please, I think maybe go to Roma and get a hold of them, and they can maybe forward you on to me. I hope you enjoy the web seminar. Thanks, Roma, and thanks for your participation, guys. Thank you.
Yeah, I'll just sum up a little bit here. And I think all of us have understood the importance of Templager And I think everyone would know that people like Syntex, Balaji, PRC, Reliance, Fixoban, and many others are using.
Yeah. Low? Can't hear you.
This went off, sorry. I said a lot of people are using it. Syntex, Balaji, PRC, Fixoban, and many others are using it. And I think Cavalry is about to get it. And I think many more people will start using the temp logger. We can see Gary's progress when he started in 79 with just 200, 300 kilos per day, probably going to 350 tons a month in just, 2 years, which is amazing. The temp logger, we are impressed to see, can measure, sorry, again, go ahead, Gary. Yeah.
You can go. I'm finished. Thank you. Thank you.
Yeah, temp logger can measure temperature inside the mold, as we saw the surface, and get the precise conditions that is required inside, and that will help us heating and cooling correctly, and provide, make sure that mold is heated and not the machine. The road simulation was very impressive. It saves in helping the waste and time, and it's really amazing to see inside what's happening. And Gary, of course, has unique methods of reducing ribs and kiss-offs, and cooling of flange, heating of flange, and solving 90% of the problems. And to get more answers, a lot of people were there, but obviously Gary needs a lot more details. So I think people should write in emails. It's difficult to explain to them the problem verbally, though they'll have a chance to have a good question-answer session, but they should write in detail, and Gary would get back to them. His email is available, And of course, finally, Gary was saying the problem is very important, and the importance of heating and cooling is very critical, bubble dissolving, quality consistency, and distortion, etc. Some of the features. So that was very interesting. And thank you, Gary. Thank you for everybody listening in. And I think over to Vipul.
Thank you, guys. Hopefully I'll be able to see you in real time in India soon.
Strategy, over to you.
I just wish to add one thing. I think Gary Infra was the first to buy a temp logger in India.
Yeah, at the great vendors.
Yeah, good afternoon, everyone. Thanks to Mr. Gary for the wonderful presentation. He has shown what is happening inside the mold. That was a wonderful technology by temp logger. It is a time that we Indians should use this technology for our application to upgrade our technology. I hope the Mr. Gary's presentation was very informative and useful for us. I also thanks to Mr. Vijay Joshi, who has come and given the presentation, and we welcome to our Roto Molding Association and Roma family. Mukesh Bhai has also given a good presentation after the COVID-19 for what is the impact on the roto molding industry. I thank Mr. Mukesh Bhai. As you all are aware that Roma is conducting the regular seminars and webinars during this COVID-19, and later on also in coming year we will also conduct the continuous seminars and webinar. So now it is the opportunity to all the members that they should become a member and avail the facility of Roma membership. This is the fifth the international speaker seminar and the webinar where very renowned international Mr. Gary is giving the presentation to all our Indian members. It is a very informative and things are there. So we request our members that Roma is presenting the webinars, so they can sponsor this webinar and give their support to the Roma and the roto molding industry. We have also introduced, last time I had told that we have also introduced the advertisement features in our websites. So anyone who is interested to give their advertisement, they are also welcome to give the advertisement, and they can contact Mr. Vipul Bhai or Mr. Venkat for the further details. As and when we are conducting lot of things, last time as I told that we have made one WhatsApp group where business to business forum B2 which group is there, where business to business things can be availed, where buyers, sellers and the vendors can come on the same platform with their requirement. This is the totally free of charge facility provided by the Roma for the Roma members. So I request people should become more members and take this opportunity. This is the right time to give the take the membership. In fact, we are coming up the new features for our membership, and we can give the special discount or to avail this opportunity. The details and other things can be availed by Manoj Bhai or Vipul Bhai. As we are regularly conducting the webinars and seminars in this feature, we request our members that they can also participate and they can give their presentation in the webinars. For that, you can contact Manoj Bhai, Vipul Bhai, or Mukesh Bhai, and it can be either any suppliers who has got a good idea which can support our rotomolding industry in India. They can also come forward. Definitely, Roma team will consider their proposal, and we will give opportunity to them in the presentation. In this series, now that I have just offered the, I would like to give the thanks to our sponsor partner, especially special thanks to the Reliance and Matrix, who has always given support to us, and our silver sponsor who has given the commitment for the complete year for the sponsoring all the webinars and seminars, especially the Arihant Plast, Turbo Plastic Blends, Hira Roto Plast, ML Industries, Pius Rotomet, even our financial institute ICICI also, they have also given the support to us. The Puja Rotomec and Swastik Rotomec, they have also given us support time to time. So we thanks Roma team, thanks to them that for their support, and we feel that in future they also give the support to us. Now in this series, now we have the next seminar we are conducting on the 23rd May of this month, where we have Mr. L.K. Singh from Pixopen and our Vice Chairman, Mr. Vice Chairman FGC Board. He is going to give a very interesting presentation on that topic and experience of cast aluminum roto molding molds. That is a new line for the Indian markets. He is going to give a good presentation. So I request all the members to block the 23rd May date for this presentation. Before I conclude, I want to give one condolence. Our FGC Board Director, C. Nayan Bhai, Director Nilkamal Limited, has recently lost his mother. Our deep condolence to the family, and may God give them the strength to bear the great loss. Thank you, and I request Vipul Bhai to give the vote of thanks before we concluding this meeting. Thank you.
Yeah, good afternoon, friends.
Before
yeah, Manoj,
can have that one question answer. Yeah.
Anybody has questions? Anybody can ask questions here.
Gary, can I ask? Gary, are you?
क्या चाहिए तेरे को? तो 2 मिनट रुक लो यार.
Hello, Gary. Your mic is muted. Please unmute your mic, Gary.
Gary, you have your microphone mute.
Yeah, sorry. One question is from Sandeep Desmukh. He is asking what is the effect of a pigment in mold release? What is the role of a pigment in effect of pigments in a mold release? You are not audible, Gary.
We have to unmute him.
Just a minute. Huh? Yeah, just a minute.
There, okay. Sorry, yeah. Somebody muted me. I couldn't unmute. Sorry. Guys, if you cut me off, you must listen, and I can't answer questions if I'm cut off. Sorry, the question was, just go again. I was trying to get connected. Sorry, what is the question again?
Effect of pigments in mold release.
Effect of pigments in mold release.
Yeah.
Wow. Okay, that's a big question. First of all, are you using a proper mold release, or are you using diesel, and what are you using? You know, I've seen such horrible things that people call mold release, which aren't mold release. So I need to know what type of mold you're using, what type of release you're using, and then are you doing dry blend with pigments? What kind of pigment are you using? It's a lot of things, but pigment will normally migrate to the surface. And if you're using a wet release agent or tacky release agent, pigment can stick to it, so you can get what we call plate out. Plate out will affect your whole product, your look, your quality, your strength, everything. So there's lots of problems with pigment and release agent if done incorrectly. If you have a good pigment in a good powder, mixed at a good temperature with a good release agent, baked correctly, you will have almost zero problems. Queen's University and lots of experts keep telling me that dry blend is no good for mechanical parts. I made about 120 below ground tanks a day, all dry blend, and I never ever had issues because we did it correctly. Hope that answers the question. Anybody?
More questions.
Gary,
Sorry?
I want to ask if
Mr. Odiwala.
storage tank, right?
Sorry? Mukesh, I can't hear you.
Mukesh, repeat your question.
I can't hear Mukesh.
Yeah. 1,000-liter water storage tank overhead made in 24 kilograms with ribs and without ribs. What is the difference?
Mukesh, 1,000 liter, I'd never ever consider having ribs. I can prove to you over and over it would just waste material and cause problems. And where are the ribs? Are the ribs roof? Or are they loose? Or they tank up to 60,000 liter. We've even got 62,000 liter tanks without a single rib in it. So I would never understand and can't understand why you put a rib in a 1,000 liter. Okay, it's just ludicrous. So yeah, and every time you put a rib in, you have a chance of a problem. Also, this is how long is a piece of string? What is the shape of the rib? The rib shape is going to have the biggest effect on your question. If you've got a square rib, absolute no. If you've got a very shallow 5 millimeter deep rib that's got radius on it, for looks, maybe. So yeah, too many things again. You know, unfortunately, it might sound all the time like I don't want to answer the question. I can't give you 100% answer unless I have 100% input. But as far as I'm concerned, why would you want ribs? And especially in a small tank like 1,000 liter. It's crazy. I know, sorry. Sorry, Mukesh, I've heard from a lot of Indians that they want.
Does the material play the role for ribs and without ribs? Do you require another kind of material where without the rib, the tank can be as strong and sturdy?
A lot of people come to me, and I'm sure they come to Reliance and all the material suppliers and say, we need a more stiff material. I say to people, number one, if you don't have a good powder and you don't process properly, you are not getting your mechanical properties. So Reliance or any other material supplier can keep giving you higher and higher densities, and you will not get the material properties. So I say, before you change anything. And before you look at ribs for stiffness, grind properly, molds properly, pinhole free, bubble free, and get the real properties, do drop tests and check that you're getting the properties, and 99% voila, you don't need anything more. Okay. Too many, by the way, too many guys in India use too low density for water tanks. Density for water tanks should be, in my opinion, 938, 939. Okay. Should not be the 936s and the lower. So that also, yeah, can talk on that one for half an hour. Does it? I hope that gives you some idea.
Thanks, buddy. Really, thanks.
Okay. All right. Anything else?
Vipul bhai, over to you.
Yeah, good afternoon, friends. Honorable Roma members and non-members, respected speakers and sponsors, and my dear Roma FGC board members. I feel honored and privileged having an opportunity to offer vote of thanks on this memorable occasion. First of all, I would like to thank you all the senior and superior for showing trust in Roma. I'm extremely elated to announce the successful closure of today's fifth webinar. We got overwhelming response and love of across the Roto fraternity. We sincerely thank to all the Roma members for attending the series of webinars and getting knowledge enhancement and learning. Very soon we will be meeting again on 23rd of May for the next webinar, which has been announced by Sethi ji. Thank you very much all. Once again, stay safe and stay home. Thank you.
Okay, guys, thank you very much. It was interesting. Look forward to seeing you shortly. Bye. Bye.
Thank you, everybody. Thanks to the speakers.
Looking forward to a nice cold kingfisher.
You deserve it.
But you can have a good kingfisher today, Gary.
I've got a kingfisher tin there, but no kingfisher in it somewhere.
Not in
Or
big
an
town.
old monk.
I've got lots of old monk. That I've got plenty. So yeah.
Great, guys. Thank you.
On a final day, we're all cheers. Old monk, still the rules.
Yeah.
Cheers, guys. Thank you. Hope you will enjoy it. Bye.
So, getting everybody.
Okay. All right.
Thanks, everybody.
Cheers. Cheers. Bye. Okay, we get it. Bye bye.